This is the 29th lecture in the FOA series on optical fiber. In this lecture, we'll be talking about plastic optical fiber, or what we in the industry call POF. This video was produced in association with POFTO, the Plastic Optical Fiber Trade Association, POFTO.com, who provided much of the graphics and technical information used in this video. Plastic optical fiber, or POF, is a multi-mode optical fiber, obviously made of plastic. It's usually a large diameter core fiber with a very thin cladding which traps the light with total internal reflection. Typically, POF is used for short, low-speed links due to its higher attenuation and lower bandwidth. This slide shows the typical size comparisons for both glass and plastic fibers. A multi-mode fiber has a core diameter of about 50 microns and an outside diameter of 125 microns. Single-mode fiber has a core diameter of slightly less than 10 microns and an outside diameter of 125 microns also. A typical POF fiber, which we call a 1 millimeter fiber, has a core diameter of about 950 microns and a cladding outside diameter of about 1 millimeter. So it's much larger fiber. Like glass multimode fiber, POF comes in two types, step index and graded index. The step index fiber has a core of one type of material surrounded by a cladding of lower index material that traps the light inside the core with total internal reflection. Typically, these fibers are high numerical aperture and low bandwidth fibers. Graded index POF, just like graded index multi-mode glass fiber, has several layers in the core to increase its bandwidth. It typically doesn't have as many layers as glass fiber, so the compensation isn't quite as well. But more layers and a lower numerical aperture can be used to provide more bandwidth capacity for high bit rate applications. Another big difference between glass fiber and plastic fiber is the attenuation coefficient of the fiber. POF typically has a much higher attenuation than glass fiber. On the graph to the right, take a look at the PMMA POF at the top of the chart and the single-mode glass fiber at the bottom. PMMA POF, shown at the top, has an attenuation coefficient of about 100 dB per kilometer, while single-mode glass fiber, shown at the bottom, has an attenuation coefficient of well under 1 dB per kilometer. Notice the difference in the wavelength where the attenuation coefficient of each fiber is the lowest. The PMMA POF has its lowest attenuation in the red part of the spectrum, where red LEDs and lasers are typically used as transmission sources, while single-mode glass fiber has its lowest attenuation somewhere out around 1500 to 1600 nanometers, where lasers are used in the far infrared region to get the longest reach for high-speed single-mode systems. Because POF cables are typically premises cables and don't need to be pulled long lengths like outside plant cables, they don't need lots of strength members or fancy jackets to protect the fibers. So a lot of the POF cables are simply a plastic jacket extruded over the plastic fiber. But there are other types of cables, including multi-fiber cables inside of a single jacket, and even ribbon cables that can be used for instances where multiple links are needed, even running them sometimes under carpet. Where is plastic optical fiber used? Well, a lot of it is used in consumer electronics. It's also used in data communications, industrial automation, in automotive links, sensors, and for illumination, like those Christmas trees that use fiber optics. But it can also be used for interesting illumination projects like clothing, as shown here. Consumer electronics has used plastic optical fiber for years because there have been versions of FireWire and Toslink digital links using plastic fiber. In fact, most consumer electronics will have digital audio or video out over an optical link, as shown here on this Toslink port. Optical fiber is used in lots of industrial applications because, being optical fiber, it's immune to electromagnetic interference, EMI, and it's very flexible. So welding robots, like this one building a car here, use plastic fiber on the arms to allow them to carry digital signals in a very adverse electrical environment. Plastic fiber is used in lots of automobiles too. There are two types of typical systems. Most connects the dashboard and the audio, video, phone electronics in the car and creates a ring-type network using the connector shown here, which combines optical and electrical contacts. FlexRay is used for safety systems like airbags. Plastic fiber can be used for lots of applications in data communications, where it can create typically short links, but even very high speeds up to a gigabit per second at lower cost than a typical glass fiber link. The place to go to find out more about plastic optical fiber is POFTO, the Plastic Optical Fiber Trade Association. They are a trade association of plastic optical fiber manufacturers and suppliers. They publish a guide to POF products and a directory of suppliers. Their website is pofto.com. There are lots more FOA YouTube videos available to help you learn more about fiber optics. You can find our lectures on fiber optics, lectures on premises cabling, and hands-on videos at the FOA YouTube channel, the FOA Inc.